Welcome to the dancer and the conductor. We're going to be talking about choreography and orchestration and long-running asynchronous processes. Just to give you a flavor of what we're going to talk about, here's a recycled slide from last year's conference. That is still no moon. That's a Venn diagram. And the point is that long-running asynchronous processes, those are part of a greater whole of the concept of microservices. So that's what we're talking about. If you're already familiar with the basics of evented microservices, a lot more of this talk will probably make sense. But if you're not, that's okay, because we're going to do a crash course through those basics. So like Dave said, I'm Ethan. I've been doing microservice development for a couple of years now. I'm writing that book. And here's yet another recycled slide from last year. I've been to a number of talks here today, and a lot of them give very specific answers to problems you might be having. Unfortunately, this is not going to be a specific answers talk, but what I'm hoping is that you'll leave here being able to ask yourself the proper questions to apply these ideas to the systems that you're working on. So that's really our goal here today. So let's dive into that crash course. Here's the deal, y'all. Software is really easy to write, but it's hard to change. I'm sure that any of us in this room, we could sling some code together to accomplish some sort of an objective, and it would probably work really well. But would we be able to be productive on it a year later, 10 years later? Could we bring in new team members and get them up to speed quickly on the project, or would it take them a while to do that? I don't know. One of the problems we have is that most of the web frameworks out there tend to optimize for writing code rather than making it maintainable. I'm going to pick on Ruby on Rails because I worked with it for a number of years, but it was amazing for short-term productivity. I haven't seen a tool that you can get something up and running faster than I could do it with Rails. But unfortunately, what it tends to do is it makes easy things trivial, and it makes hard things nigh unto impossible to do. And the reason for that, it has to do with coupling. Coupling is the enemy of change, right? If two things are coupled together, you can't vary either one independently, and that makes it difficult to change things. And Ruby on Rails in particular pushes you towards a monolithic architecture. Those are architectures with very high degrees of coupling. Now, it's not bad for prototyping apps, and it's not always wrong. Sometimes you may have a reason that you really need to produce something in the short term, like maybe you need to prove some results to get funding. That matters. Keeping your company afloat is an important thing, I'd say. But these monolithic architectures, they're less not bad, or they're not very good at long-lived systems. Okay, and I'm going to make a big distinction between apps and systems. And in addition to the monolith, there is the monolith's less pleasant associate, the distributed monolith, which is, let's take all the pains of a monolith and add to it all the pains of a distributed system. But I think that if you have a monolith and it's hard to work on and you go to the blogosphere to try to find some help with it, most of the articles I see are going to push you towards something like this. And I think it's because of a fundamental misunderstanding of what makes something a monolith. It isn't programming language, it isn't the number of computers it's running on. It has to do with this. It's your data representation. So on the right side here, in this exciting gray box, are the kinds of fields you might see in a users table in an application. How many of you work on systems that have the concept of users? Yeah, that's most hands there. Probably all of them. I just didn't keep looking long enough, but that's all right. On the left side here, we have different concerns that might be in your system. But what's this? Okay, we've got payment info on the users. That's clearly payments information. We have an address. That sounds like shipping. And then we have an email address and a phone number. That sounds like notifications. An email address and a password. That sounds like authentication. A role. That sounds like authorization. So we have, on this one data object here, 5 different concerns worth of data. That's the monolith. Right there, when you have all these various concerns tied up in a single object, or schema in this case. I can't change this without worrying about breaking at least 5 different concerns in the system. And that's why Putting it on a different server behind an HTTP API doesn't change the fact that it's still a monolith. And here comes one of my favorite parts. So I've been told this can be difficult to see. That's a picture of the monolith from 2001: A Space Odyssey. So let's do some math together here. If I have a monolithic database and I add to it an HTTP API, would anyone care to hazard a guess what I have at the end of this? A monolith, yes. And due to product offerings from AWS, we need this next one. If I have a monolithic database and I add to it an API gateway that forwards a call onto an HTTP API, what am I left with on the other side? What was that? A microservice, did you say? Yeah, it's a monolith. Okay. So then what defines a service? That's a fair question. Autonomy. The concept of microservices was born out of something called SOA, or service-oriented architecture. And in there, there was this article that had the 4 tenets of SOA, and one of them was autonomy, and that's the one I'm going to focus on here. Services are autonomous. No one asks a service for anything. A service doesn't have a GET API. If you're asking something for information, architecturally speaking, that thing is called a database. There are databases that ship with the ability to serve HTTP requests. That doesn't make them anything other than a database. So even if you take some piece of data and put it behind your own thin layer of HTTP, you're still talking about a database, possibly an application, but certainly not a service. Services don't ask anyone else for anything. If they did, they would depend on that. And dependency, that's the opposite of autonomy. And the third one's really a corollary of the first two, is that a service really isn't even aware that anything else exists in the system. And that has some really neat properties. So think about testing, right? If I can't tell that there's anything else in the system besides me, can I tell the difference between being embedded in the production system or being embedded in a test harness? Like, from my perspective, there is no difference. If I'm trying to bring a new team member up to speed on the project, wouldn't it be neat for them to not have to be able to run the entire ecosystem to be able to work on the thing they're supposed to work on? You can do that with autonomy. So they sound like they have the properties of both black holes and white holes. So how do you get them to do anything? Well, they communicate asynchronously with asynchronous messages. There are 2 flavors of those, events and commands. I get to use a prop for this part if I remember to bring it. Here's a pen. So if I have a pen and I drop it, action-packed, but now reality has registered a pen dropped event. I can't argue at this point, right? I may not like that the pen is on the floor, but it is. That's the past. That's just the way it is. I have to deal with it. I get to choose in my system the names of these types. I notice that's in the past tense. It's not a pedantic point. Like, it really helps with understanding. And again, you just have to deal with events. They have happened. On the flip side, there are commands. Notice this one is in the imperative tense. And it's when you tell the system, hey, I want you to do something. Now, it may not want to do the thing or may not be able to, given the state of the system, given the current, the business rules. That command may get rejected. Like, if you say to me, transfer $1 million to someone, I might say, you don't have $1 million. I'm not going to transfer it. That's perfectly valid. Or it might be valid and happen, in which case more events would get emitted. So being at a JavaScript conference, we're probably really familiar with the concept of events. It's probably worth pointing out, I'm not talking about things like button clicked or window resized. We're talking about domain events, so interesting occurrences in your system's domain. If you're working on an e-commerce platform, a domain event might be item added to cart, order placed, payment received, not button clicked. So that's an important distinction there. And then we can take it a step further and introduce the concept of event sourcing, which is where those events, they're not just communicating information between things in the system, but we actually store those as the state. That's the authoritative state. So if you've done some web apps before, a relational database table like that might look familiar. So if this was a pens table, pen 1 is now picked up, and that kind of data might look familiar, but we're not actually storing that as the authoritative state. We're storing that sequence. The pen was dropped, then the pen was picked up. We can shape it into this if we want to for quick reads, but that's our authoritative state in the system. Okay, a little bit more of the fundamentals here. If you build a system this way, what are the kinds of components that you would see in it? Well, first of all, you're going to have services, right? It's right in the name, microservices. Services are doers of things. They're not representations of things. So you might have a service that sends emails or sends SMS messages. There are applications. What are those? That's probably like your Express server. It responds to requests from the outside world and renders responses. It issues commands to the event store there that can get picked up by the services, and the services can emit events back to the event store. If the application is going to render responses to the users, it needs to have data to do that. It gets that data from what are called read models, and read models are populated by aggregators. And this is total fire hose here. And of course, none of this implies that we're dealing with a distributed system. You can have a microservices architecture that is not distributed. The deployment concern is important, but it's not what defines whether or not you have services. Okay, that's the end of the fire hose. I am certain there's at least one question that someone has in this room, and I'm going to stand right here until I get that question.
Can you repeat this last slide? Say it all over again.
This one here? Yeah, perfectly. Yeah, no problem. So basically, I guess there are 5 different things you'd see in a system like this. At the center of it, and all the communication flows through here, is an event store or a message store. So events and commands, they get written to that. And all the other components can see those in a pub/sub manner. So like anyone writes to it, it's now available to everybody. You don't know who is going to read it. It's your job to write something there. So the application, that's like an Express server. And these are our happy users because we're professionals. And they send requests to the application depending on what they're doing. Like, let's say someone is trying to initiate a bank transfer. We'd write a command to the event store saying, hey, transfer these funds. And that command object would have what account it is and how much and so forth. A service is going to observe that, a transfer service perhaps, and it's like, oh, hey, I respond to this. This is my job. It'll look at the command. It'll look at the current state of things, make a decision to either reject it or to let it happen. In either case, it's going to emit events like no transfer rejected or transfer succeeded. That's going to be in that log of events that we saw, where is it? On this slide. So we'd have like a list of events that had happened for a transaction or an account. That makes for really cruddy user interfaces. No one wants to see that except for auditors. If you're an auditor, that's a great interface, but most people, we want to look at our bank account and see a balance. So that is the job of, so hard like pointing in the right place. That's the job of the aggregator. So it's going to be observing all of these events, and it just rolls them up into views over here that the application can quickly query and hand back to the user. So in the example of a bank account, your account would have a number of events associated with it. The aggregator would take all those and roll them up into like one row that's like your account, here's the balance. So it can quickly show that to you. But that one row is not really where your account balance came from, because that would be horrible. What if you argued with your bank? You're like, no, I don't think that's my balance. And they're like, well, that's what the column in the database says. No, they keep the record of every transaction so you can reconstruct it at any point in time. Does that help? Did I explain that better?
Yeah.
Okay, awesome. All right, let's move on then. Unless there's like any burning questions, but okay. We're talking about long-running processes, okay? So we're in this world and we have something that's going to take a long time to process. I mean, it's not really about the length of time. I shouldn't say that. But an example, if you placed an order on Amazon.com, that's not something that instantly resolves. And so let's reason together. What distinct steps do you think might happen when you place an order with an e-commerce store? Let's imagine we're talking about physical goods as well, not like a ebook or something. But what interesting events in the domain of e-commerce happen when you place an order? Charge a credit card, yep. So payment received, that's something that's going to have to happen if you want to stay in business. What else?
Inventory needs to be updated.
Inventory needs to be updated.
Shipping calculated.
Shipping calculated, yep, exactly.
It's going to verify the inventory is available.
It would need to do that. Yep. Send an email. Yep, you're thinking about it exactly right here. I just listed some things on the slide because I didn't want to live type these because that wouldn't have worked very well. But yeah, exactly. thinking about the business processes there. Those are the events that need to happen. Those are going to get put into the event store because those are the state of the order. And what I really like is notice how, as we're talking through that, you're starting to think in terms of business processes and not jumping straight into creating records and databases, updating them or deleting them. Those are very crude tools. Thank you. I'm here for the rest of the week, everybody. Anyway, so let's take a really simple case of a quote-unquote long-running process, basically something that involves more than one step. In a traditional MVC app, this might all live in one function as a number of lines, but that's not our case here anymore because these distinct steps are carried out by different components in the system. So let's say you have a site where users register and you want to send a registration email. That seems like a reasonable thing to do in a system. So there's two main methods to think about this. One is choreography. And so there's a picture of ballet dancers here. I just want to say, I know you had at least 2 other options for where to be during this hour, so thank you for coming to this talk. That honors me. I will honor you all by not attempting to mimic the movements of a ballet dancer. Consider that my gift to you. But in a ballet, all the dancers, they individually know what they're supposed to do to contribute to the whole. And so that's how it works. There's no central person like dancer A, you need to go there right now. So let's take that mindset when looking at sending an email on registration. So we receive a registration request from the user's browser. And so we're going to emit a user registered event, because in the application, we can do the preliminary checking, yep, this looks like an actual email address, et cetera. And we publish that to the message store. And we have a send email service that's like, oh, a user registered. I do something with that. And so, see the excitement in there? That's an exclamation point. It should send a registration email. Now these little icons here, or shapes as Google Slide Presentations calls them, slides, whatever they call it, that doesn't matter. What matters is what these are for. I'm trying to map the concerns that are going on here. So we have a concern of actually being able to send an email, whatever that is. We don't care about the contents of the email. That concern is owned by this service. The concept of what the email looks like when someone registers, that's what the triangle represents. That's also contained in this service. So it kind of has 2 things it's dealing with right there. The actual mechanics of sending emails, whatever they may be, but then also the specifics of a registration email. This event would contain all the information this service needs to actually send that email. So that's one way to think about it. The other is orchestration, and this is a conductor. In an orchestra, the members of the orchestra, they know how to do their individual jobs, but they look to the conductor to guide their contribution to the whole. I played in high school band. I played auxiliary percussion my senior year, and I remember we had a conductor. That's about my experience with music in that way. So it's a very different model. So rather than each member intuitively knowing what they're supposed to do, they look to the guidance of a conductor. And we can have this model in our system again. So slight change, when we get that request from the user, instead of emitting an event directly, we're going to emit this register user command. And that's going to hit the message store. And what's going to happen is the register user's service now, this is a service in its own right, it sees that command and it's like, oh, I need an email to be sent. So it's going to generate the contents of that email, issue that as a command to the message store. Send email service is now going to pick that up and send the email. Now the difference here is that, remember those little concern icons that we had? They're over here now. The mechanics of sending emails, that still belongs to send email. But the knowledge of what a registration email is, that belongs to this new service called register users. Right? So previously, send email had to know about registration emails and sending them. In this one, register users is kind of the conductor of the process of registering someone. It now owns the contents of the email, so the actual email template that would live inside this service. Does that make sense, like the difference between those 2 approaches? Okay. So we're going to look at an example here. How am I doing on time? Do I have 7 minutes left? Okay, awesome. 13. Oh, I'm really glad to hear that. 17, even better. Okay, so the process that we're going to look at here is suppose you're at a company and you're hiring new employees. We're going to say they're developers because this is a JavaScript conference. That's what we do. So what are the kinds of things that might happen when you hire a new developer? You might use GitHub, so you need to get that developer access to GitHub. You might use Slack. If you're unfortunate, you use Microsoft Teams. I just started using that at a new job, and Slack's got its issues. Teams also has its issues. In the United States, you have to collect I-9 information about employees. You need to set them up in the payroll system. You need to set them up in benefits. I've never actually built an HR system, but I've been hired at places, and these are the kinds of things I've had to do. So this is just kind of an idea of what interesting domain occurrences need to happen when I hire somebody. So let's choreograph it, shall we? Here's a really messy slide. I apologize for that, but let's break it down. What do we have? We have a couple of applications. Applications are things in a system like this that use, dare I say, apply services to achieve business ends. So we have two of them here, because we can have more than one, even though it was in one box in the other slide. We have a message store for communication, and we have a number of different services here. We have a send email one, grant GitHub access, provisioning payroll, provisioning benefits, and granting Slack access. And I've done a similar thing where I've given a different shape, and hopefully they are distinguishable from way in the back. And then over here we've listed what those concerns are. So for example, provisioning benefits is in charge of provisioning benefits. That's fascinating. But okay, so let's see kind of the flow that happens here. New hire comes in, someone types into, let's say it comes from some other application, that we have this new employee, and it probably shouldn't have been a user registered event, more like employee hired event. So just pretend that's what that says, and that goes to the message store. Now this is pub sub, so every service is going to see that message, but not every service is going to care about it necessarily. In this case, every service does. So we see a lot of reactions that happen all at once here. Send email, just like in our simple example, gets all excited and sends a, hi, welcome to company X. Sorry you use Microsoft Teams. There's another, whoops, getting ahead there. There's a service that handles granting GitHub access. Maybe it makes an API call and says, grant this user permission. Provisioning payroll is not really to operate yet because it doesn't have I-9 information about the user. It also doesn't have benefit election, so it doesn't know what to deduct. That's why it's in a thought bubble, because it's not actually doing anything yet. Provisioning benefits, you have to wait 30 days before you get benefits at this company. And the Slack one is like, woohoo, now you have Slack access. So again, the one event hits, it goes out to everyone, and everyone knows what they're supposed to do immediately in response to that. There's no central coordination of this, it just happens. Time goes on, the employee types in their I-9 information, that goes to the message store, goes out to everybody. The provisioning payroll thing is still like, hey, I don't know about benefits yet, so I don't know how to set up your paycheck. Although, in a real system would probably default to just not deducting anything. But we're focused here on the flow through the system, not the specifics of writing HR software. So at some point, they're going to actually make their benefit selections. That's going to go to the message store. Again, everyone's going to see it, but not everyone needs to respond to it. And then provisioning benefits is like, oh, okay, I've got this. Now the benefits are provisioned. They're set up with that. They'll get their ID cards and whatnot. And payroll's finally like, okay, you're set up in payroll now. And that's kind of the flow through it. So no one was telling the services individually what to do. They just observed things that had happened and responded to them. And that has some neat pros to it. What if we wanted to put a new step into the new hire process? What if we wanted to, oh right, here we go. Didn't need that part, that's a mistake on the slides. What if we wanted to order headphones for a new employee? We could just add a new service that when an employee gets hired is like, oh boom, I'm gonna send an order to Amazon for a pair of headphones. None of the other parts of the system had to change to allow this new behavior, right? Because there's no central controller of this process. If we want to add this new element to it, we just add it. It does its job because it's observing the same events as everybody else. And of course, it would report its status and whatnot. But it has some negatives. What happens if something goes wrong? Like there's the golden path where everything works, everything gets supplied in enough time. But what if after, I think it's 3 days, most people are like, if you don't bring in your social security card, driver's license after 3 days, you're out. Like it's a big deal. Companies don't like getting sued. Maybe some do, but I don't know. Anyway, so after 3 days, the payroll system's like, hey, we never got the I-9 information. So that event gets published, but we need to undo some things here, right? If the employee's not going to be working here anymore, we probably don't want them to keep having access to GitHub or Slack, or maybe they got some AWS access. Probably need to shut down their benefits and whatnot. But if I'm going to do that, like if I'm the GitHub service here, the one that grants access to that, and I need to revoke it in response to I-9 info never being received, now I've got to watch for I-9 info never received events. I now need to be aware that there's a payroll system in the system that I'm sorry, a payroll service in the system that I'm embedded in. And that feels kind of, I don't know that GitHub should have to know about payroll events. But for send email, it's like, how do you undo sending an email? Like call the person and be like, hey, could you delete that email that we sent you? So that one probably doesn't matter as much, but there's some of the other ones here where needing to undo makes it kind of weird to model a system this way. Any questions about the choreography at this point? Yeah. That is a perfect lead-in. I swear, did not set this one up before this session. Oh yeah, here's the point. Everyone needs to be aware of everyone's failure conditions. Let's take this same problem, and now let's apply orchestration to it and see what that looks like. So same setup, only a different picture in the upper left, because now we're talking about orchestration. So same concerns, same services, same flow. Oh, dude, totally just gave away the punchline here. My bad. Okay, so here's the whole system. Here are the various concerns in here that each of these things represents. But is there some concern, something that we're leaving out of this slide currently? Like we have the distinct operations listed out, but is something missing?
A red cube.
Yeah, I probably represented it as a red cube, or I probably would represent it as a red cube. But anyone, any guesses of what the red cube represented? What was that? Not event prefixes. Order? Yeah, let's go with that. The process, right? The process of onboarding a new developer with all this paper pushing stuff, like that's a thing. That's a concern in this system, right? I mean, that's not quite an entity, but that's a real concept. In the choreography thing, we have a flow that happens when someone gets hired and needs to be onboarded, but we've taken that thing and we've split it up amongst all these different services. And what was really cool before we had the red cube was that each box pretty much just had one thing that it worried about. But in this thing, we've kind of implicitly put the process itself a little bit into each of the different cubes. What if, huzzah, we made a new service that owned the process? What was that? Oh, people coming. Okay. Yeah, so we can make a new service that doesn't necessarily represent any distinct operation, but it represents the process of onboarding a new developer. So what does that look like then? Well, same thing. We get a command from the application to onboard a developer. And it gets excited. It's like, oh, now it's time for me to go to work here. And it starts issuing commands. I need to send an onboarding email, grant GitHub access, grant Slack access. Notice again, these commands are all going to the message store, so it has no idea who's fulfilling it. But the process of these distinct steps that needs to happen, it owns it, it knows it. You can go to one place and see what the process is. And of course, et cetera, because who needed 3 more slides that look just like that one? So there's a pro to that. The knowledge of the process isn't distributed anymore. It's in one location. And that's pretty cool. That makes some people feel more comfortable, being able to see everything in one place. If there is an error, that's a little bit easier to recover from because in my mind, it makes more sense for a thing managing this process to be aware of the failure conditions of the individual steps, right? So if you're the onboarding process and you're trying to get I-9 information submitted, you're probably aware that that might not happen. So when that failure event happens, you're kind of the right place to deal with that. But it has some negatives to it. If you want to add a non-trivial change, you've got to go change the orchestration. Remember in the choreography example, when we added the headphones order, we didn't have to change anything to make that happen. We just added that part in. Well, if we want those headphones to occur in this case, we need to go change that orchestration flow. So maybe that's a con. Another one is these processes could go really big, and then you've got this monster process all in one place. I don't know if that's wrong or not, but maybe that's a problem. So which one should you use in your systems? Who says orchestration? Wow, who says choreography? The total number of votes did not add up to the number of people in this room. That's okay. Here's the ultimate showdown, and what's the answer? Yeah, it depends, and you can use both, right? These aren't mutually exclusive. So think about the system. What things do I need to roll back? What things can I roll back? That is a pipe separator there. In this font, it looks like an I. So it's like what things need or can be rolled back, but need or can, that's what I was going for there, yay fonts. But for example, I can't roll back sending an email. I can't roll back sending an SMS. I could maybe roll back ordering the headphones, but maybe I'll just keep the box of them for when the next person joins. I could send them back, but that's kind of a pain. I probably do want to roll back payroll. If the person isn't working here anymore, probably don't want to cut them a check. They would like it, but the business wouldn't. Want to revert Slack access. I want to revert GitHub access. I want to revert benefits. So I can do a mixture of the two. So when a user registers or that command goes out, maybe the email service just immediately responds with a, hey, welcome to company X, sorry, we use Teams email. We could send an SMS about it, we could get the headphones ordered immediately. But then for the other things that kind of have more of a flow and more important failure conditions, maybe I would orchestrate those, and that's totally legit. Any questions then about, yeah?
Why would you just, in the orchestration example, why would you just send it to the user event instead of having it know? Like you talked about that undo stuff, you might not do it. Why would you just say now delete it instead?
Okay, so the question was, why not, when something fails, just delete the user out of the system? Have that be its own event. That's a fair question. So let's go back a few to, where'd it go? Don't know why I'm pointing at that screen when it's right here. But, okay, so the events that are in this, a system like this, they're domain events. So they're specific to the domain of the system. It is extremely rare that the CRUD verbs are domain events. Like that's database lingo, not HR lingo. For example, like when someone registers for your site, we might think of that as creating a user, but that's kind of a bold metaphysical claim because that's saying that the user sprang into existence at the moment they registered for your site. It's a really good site. Yeah, exactly, right? You'd have trouble with the COPA laws in America, though, the Children's Online Privacy Protection Act. So events are always going to be domain-based, and so deleting a user wouldn't be the right event for that, but unhired doesn't sound right. It's hard coming up with the names for those on the fly. But yeah, that's what you do. So in that case with the, whatchamacallit, why don't I just look at the slide instead of trying to remember? The provisioning payroll service, when it detects, hey, it's been too long, we don't have the I-9 information, and it emits that event, the process manager or the orchestrator could just say, oh, hey, emit an event saying this user is no longer with the company. I think that's exactly what it would do. I mean, first guess, that's what I would do. And so then the other services could respond to that, even in an orchestrated manner, to revoke all the access. So yeah, fair question. How are we doing on time? 3 minutes, I think. We can do one more question. 8 minutes?
25 after, right? 20 after.
20, okay, so 3. Yeah.
I guess I'm just curious, you talked about the database kind of being the tiny monolithic part. So, like, with this distributed, I don't know, whatever you
have each of their own layer of persistence?
That's an excellent question. So the question was, if the monolithic database in the middle is a big problem, is the best way to handle this that each service has its own layer of persistence? Yes and no. So that's a complicated answer. This is part of the fundamentals we had to blaze through. But the message store here that's storing these events, that is the system of record here. Like, that's the authoritative state. Now, there may be times where, like in this one, for example, it may have its own little local data cache that only it sees, but it's just to speed up its working. So all authoritative state is in the message store, but various things can drive whatever they need to from that into the shapes that they need to carry out their jobs. Does that answer your question?
So I'm trying to move more of that state out of the database into the store.
Into domain events, yes, exactly. That lets me reshape it into whatever I need for whatever my job is to do. Okay, so to wrap this up real quick, the key takeaways. What makes something a monolith? It's a data modeling issue. It has nothing to do with deployment or language or whatever. There's a popular thing that I think is completely wrong, that monoliths and microservices, like when you start building a system, you first travel down to a monolith and then you move on to microservices. To me, that's like we're in Utah, monoliths are in LA, and microservices are in New York. And so going towards LA is taking me in completely the wrong direction because, of course, the earth is flat. So maybe that's not the best example, but the idea is like one's not a waypoint on the way to the other one. Services, they're autonomous and they communicate via autonomous messages, not direct API requests. And so even though all execution in a system like this is asynchronous, we can still have ordered processes. Choreography's approach is to let's encode that process into the various services that have their distinct operations. In orchestration, the process is very explicitly encoded into a single thing. Each has its pros and cons, and the same process can be used. Yeah, a given process can use both approaches. There's more info at the back of the slides. I have a mailing list if you want to know about the book or whatever. And I link to the slides in the slides, which makes a lot of sense. But that's so I know what to put into the Slack channel after this. Yeah, slides inception. So, and there's some other interesting resources there to help you learn about it too. Yeah, thanks a bunch. Have a good rest of the conference.